As you might expect, division of complex numbers is a bit more complicated, and there's actually a little trick to it that it's not terribly intuitive, but you need to learn it. So let's take our complex numbers we've been playing with, 1 minus 2i, and now we'll divide by 3 plus 4i. How do you divide that? Okay, well, you don't divide 3 into 1 and 4i into minus 2i. You can't do that because this is considered one term, dividing into both of those terms up there. So it's a bit more complicated, but here's how we do it. What we have to do is form the conjugate of the denominator. Now, the conjugate of a binomial term is the same binomial term but changing the middle sign. So here's what that means in a little plainer English. The conjugate of 3 plus 4i is 3 minus 4i. In other words, I use these numbers, but I change the middle sign. That's called the conjugate. And I'm going to multiply numerator and denominator by this conjugate term, because if I take my original calculation, if I multiply the denominator, I have to multiply the numerator by the same number so that everything balances out. It's the same as multiplying by 1, isn't it? Alright, so multiply by the conjugate. Together these are called conjugates. Okay. Now you've encountered conjugates before, and when you first took algebra, you saw things like this: x minus 2 times x plus 2. That is a product of conjugates, and when you multiply that out, you get x squared plus 2x minus 2x minus 4, and these two middle terms cancel when we multiply those together, and we get x squared minus 4. Well, that's the idea here. We want to produce a difference of squares, and in so doing, it's going to eliminate the i's in the denominator. So what is the point of this exercise? Dividing complex numbers is a sort of a reorganization process which eliminates the imaginary numbers from the denominator. So we'll see that happen up here. So I need to make some room. I'm going to multiply across, FOIL this out across. So on top I've got 1 times 3 is 3, minus 4i, minus 6i, and then plus 8, the two negatives cancel, plus 8i squared. Down below, same thing, we're going to multiply across here by FOILing. So I have 3 times 3 is 9, minus 12i, and then plus 12i, and then minus 16i squared. And look what happens here. Down below, the middle terms canceled, and we get this difference of two squares action. Alright, so, and furthermore, what happens to I squared? It's going to turn into a negative 1, isn't it? So this turns into negative 1. That turns into negative 1. So when the dust starts to clear here, I've got 3. These combine, minus 10i. And then 8 times negative 1 is minus 8. Down below I've got 9. And then negative cancels that negative, plus 16. And we'll finish up here. Combined here, I've got 3 minus 8 is negative 5 minus 10i over 25. So there we go. Now, this one's a little unusual. We can take it a little further. This doesn't always happen. But I can factor a 5 out of here and then cancel with the denominator. So let's go ahead and do that. I'm going to go back up to here since I'm running low on room. So if I factor a 5 out, I've got 5 parentheses negative 1 minus 2i. over 25. And then the 5 cancels the 25. So don't do any reducing unless you can factor a number out. All right, that's another algebraic principle that's pretty strong. That you, I mean, it's very important that you remember. So don't reduce a fraction unless you can factor the number out that you're going to cancel with. All right, so let's write this out. I need to make some room. So this ends up equaling -1 minus 2i over 5. Now this is a perfectly good answer to me, but practicing problems in a textbook, they will, I believe, usually split this up this way. So we could split this up as -1/5 and then -2/5 I. So there's the reason textbooks do this is because they want to stress that your answer from the original division results in a single complex number. This is a complex number because it has a real part and an imaginary part. But to me, you don't have to go this far. You can stop there. I'm happy with this answer, but I do want you to reduce it when you can. Reduce your fractions. So there we go. You've seen adding, subtracting, multiplying, and now dividing complex numbers. And it's you know, sensible that if we're going to introduce a new number system, that you learn how to do at least the basic arithmetic operations on it. Okay.